Alright, so I did an earlier recording of this for when I first started this problem, and I went down a path that was probably just too complicated in terms of I could maybe finish it, but I don't really feel like it. So anyways, for this problem where you're counting the number of values between kind of a range of values, where certain values might have a prime number of set bits in their binary representation. For instance, if 6 through 10 is the range, and 6, 7, 9, and 10 all have a prime number of set bits, so prime number 1s in their binary representation, 8 being the one value that doesn't, because it only has one set bit and one is not prime. So anyways, the way that I had it done was just using bit count to determine the number of set bits, iterating through all the values in the range. So from left to right plus 1, not inclusive right plus 1, so you include the right value. You have a set of primes that are reasonable to be the number that's on. I went ahead and went all the way to 31, although given the constraints of right being at most 10 to the 6, I want to say that 10 to the 6 is, you can have at most like some lesser number of this, like maybe 23. 10 to the 6, what is log base 2 of 10 to the 6? 10 to the 6. So it's 19. So there's just going to be at most 19 set bits. In any case, yeah, iterate all the values, count the ones that have the set bit on. The number of times it iterates is at most 10 to the 4th, so it's not all that much. And that's why this thing performs reasonably well. I will say that if this was a higher constraint, like it was 10 to the 9th or something like that, then I would be forced to do what I was going to do, which is like use kind of binomial expansion slash coefficient slash Pascal's triangle to determine the number within the range. That would be, I'd say, either medium or hard, probably closer to hard. But given that this is not part 1 or part 2, or part 1 where part 2 is the hard or medium version, I'm just going to go with it. But yeah, there definitely is a way. My mind is currently not thinking of it, but there is a way to optimize it so that you're not iterating through all the values, you're just looking at the bunches of values between powers of 2 and then doing a fast computation of those values on the distribution of prime set bits within those buckets. This is part of the work there. But anyway, so summary, the kind of easy way to solve this or to code this would be to iterate over all values in the range and have counter for the number of values that have a prime number of set bits. Use bit underscore count to determine the number of set bits of a value. That's for Python. I'm not sure what it would be for Java. Yep. And then time complexity, this is going to be O of n, where n is the range right minus left. And then basically this can be O of 1 since no space is needed.